Hi, how's it going? My name is Carl Diaz. I'm here at the Learning Resources Center, and today we're going to talk about subtracting vectors. So make sure you go back and watch the addition vector video before this one. There's a lot of information. They're just talking about what vectors are and things like this. This is just an addition to that video. I just didn't want to make it long, but this is how we subtract vectors. So let's get going with this one here. All right, as you can see, I have two different ways. Students get really confused here. So I want to make sure that you guys really understand what's going on, how we can write an equation one way to subtract and another way to subtract. And I gave the same examples here on both sides, but see how they're different, to see how we get different answers, but how it still works the same. So the method that we use for subtracting vectors specifically is tail to tail, but you can use the addition method of tip to tail, which we'll talk about here in a second. But the tip to tail method is really straightforward. You just find your vectors, right? And you place the vectors of the tails of the vectors together, like we did here. So here's A and B. I place the tails of the vectors together, and then draw the net vector from previous to later, okay? And I wrote up here who's previous and who's later on both sides. So make sure that you're cautious of which is which, because it flips over here, okay? So over here, A's the later, B's the previous, right? So we're going to draw from B to A, right? Does that make sense? Another way to think about it, I've heard it said this way, which is really helpful, is you can draw, right? When you go to draw the net vector, you can draw it from the tip of the vector with a subtraction sign in front of it. So this vector is a subtraction sign in front of it, to the tip of the vector that doesn't have a subtraction sign in front of it. So B has a subtraction sign in front of it, right? And we drew it from the tip of that one to the tip of A. That's another way to think about it, and that works every time, no matter where you're looking. Okay, you can always draw from if you place them tail to tail, you can always draw the net vector from the tip of the vector with the subtraction sign in front of it to the tip of the vector without the subtraction sign in front of it. All right. So let's look at both of these. Okay, we're going to look at A minus B, V1 minus V2, and VI minus VF. Okay. So here, I just went through the example, let's just do it again. So here's A minus B. We want to locate them, put the tails together, and then when we draw from previous, whereas B's are previous, to our later, where A's are later, or we can remember just to draw from the tip of the vector with the subtraction sign in front of it to the tip of the vector without the subtraction sign in front of it. Now, like I said, we can check ourselves. We can use the addition method, tip to tail method, to also do the same subtraction problem, but we better get the same answer. So it's good to know both because you can check yourself. So as you can see here, right, what we have to do is I have the same problem here, A minus B, but what you have to do is you have to turn into an addition problem first, okay? So when this turns into an addition problem, that negative sign associates with this vector always, okay? And then you make the addition sign, right? It turns into addition sign. So this problem, I just added an addition sign where that negative sign now associates with this vector. That's important because it's telling us to do something. So again, watch the first video for addition because we go through tip to tail, and what it is you take the tip of, or you take your first vector and draw it, then you take the tail of your second vector and put it at the tip of your first vector and draw the net vector from the tail of from the tail of the first to the tip of the second. But the thing here, right, B's pointing this way. Why is it pointing this way in this picture? Because in order to do tip to tail here, we have to change the direction. Now, I know we say don't change direction of vectors, but this is telling us that we have to. So it's okay to do it here. So we just want to flip the direction. We want to make sure that B, right, B is pointing this way, right, before we actually put it on the tip of A. All right, so here's B, right? I flip the direction, so here's B negative, right? Then I want to take the tail of B and put it at the tip of A, and then draw from the tail of A to the tip of B. Again, this is the tip to tail method, the addition method. Okay? This is how we add vectors. This is the method for adding vectors. Okie dokie. So you can do the same problem, but use the addition method, and that's what I'm showing you here, and we're going to do that with every problem. All right, so right here, this is the tail to tail with V1 minus V2. This is the tip to tail for V1 minus V2, all right? So, like we said, for tail to tail, it's just as easy as bringing these two tails together and then drawing from the previous to later, where V2 is the previous, right? V1 is the later here, so we draw from the previous to later. That's the net vector in that direction. Or we can just remember it's from the vector with the subtraction sign in front of it to the vector without the subtraction sign in front of it, right? Or if we want to do the tip to tail method, we got to first turn it into an addition problem where the negative sign associates with V2, right? Which means we have to flip the direction of V2 is what we do, right? First we draw V1, right? And then we flip the direction of V2 and put it at the tip, right, of V1. And then draw the net vector from the tail of V1 to the tip of V2. Again, this is the addition method we're doing here on this side. This is the tail to tail or the subtraction method we're doing on this side. But as you can see, they're both pointed the same way. It doesn't matter what side of the triangle they're on. It's the fact that they're both pointing the same way. Sorry, see I have an AB here. It's the fact that they're pointing the same direction. That's all that matters. So we're getting the same vector no matter which way we do it. Okay, so you gotta pick the way you're comfortable. All right, again, now this one, this is V initial minus V final, right? So we can just put the tails together, draw from the, again, following this, put the tails of the vectors together, draw from the tip of the previous, which is the V final. Sorry, I had those written incorrectly. I had B and A there, I apologize. V final. We draw from the tip of V final to the tip of V initial. Again, tails together, and then V final, right? We want to draw from the tail of V final to the tip of V initial, or from the previous to the later, okay? Or from the vector with the subtraction sign in front, the tip of the vector with the subtraction sign in front of it, to the tip of the vector without the subtraction sign in front of it. Or we have the tip to tail method, the addition method, where it's again the same problem, but we have to associate the negative sign with VF. And then we'll first draw VI, flip VF, right? We're saying that VF has to swap direction. So that is negative VF, right? So we take negative VF and put it at the tip of VI, and then we draw from the tail of VI to the tip of VF. Again, this is the addition method. Watch the video for the addition method, and this will make sense if you haven't already done it. All right, now let's look at these same problems, but written in reverse, right? B minus A instead of A minus B. V2 minus V1 instead of V1 minus V2. V final minus V initial instead of V initial minus V final. We can do it either way, but this is like the change in something, right? So either way it's done, this still sticks. So just keep doing the same exact thing that you've been doing, all right? So we're going to do the same thing again, looking at the tail to tail, then looking at the tip to tail, all right? So here for the tail to tail method, again, very simple. We take these vectors, we put the tails of them together, then we draw from previous to later. But here, it changed, right? Here, A is previous. Over here, A was the later, right? With this combination. With this combination, A is the previous. We draw from previous to later. Or we can remember this really handy thing where we draw from the vector, if it's the tail to tail method, the vector with the subtraction sign in front of it, which is A, the tip of that one to the tip of the vector with the tip of the vector without the subtraction sign in front of it, right? Which is B, right? It's that easy. Tails together, vector is going to go from the tip of the one with subtraction sign to the tip of the one without it, or from previous to later. A is previous, B is later, okay? And then tip to tail method, or the addition method, where we have this, again, we got to make sure that we first turn this into an addition problem where the subtraction is going to associate with the A, which means we're going to have to flip it, just like we did over here, right? We had to flip the direction. So B, we write that first, then we flip A and take the tail of A, put it at the tip of B, and then since this is addition method, we draw from the tail of B to the tip of A, right? The tail of our first to the tip of our last, which is the addition method, right? But again, they should match. We get the same answer, right? No matter which way we do it, whether we do it tip to tail, the addition method, or tail to tail. But as you can see, tail to tail is pretty quick, right? Tip to tail is good, but tail to tail is really quick if you get it down and just understand this, which is really simple, right? So let's do these last two. So now we have V2 minus V1. Again, tail to tail method, just put the tails together. It doesn't matter, just as long as the tails go together. So there's V2, V1, we kind of had to swap them so the tails go together, right? But the tails are together, then we draw from the tip of V1 because it has a subtraction sign in front of it to the tip of V2 because it doesn't have the subtraction sign in front of it, right? Or again, from previous to later, right? Here V1 is previous, it's not over here, but here V1 is previous. So as you can see, right, everybody on this side is previous, right? Everybody on this side is later, right? Over here, again, everyone on this side is previous, right? Everyone on this side is later. Okay, that's the way to think about it, all right? Okay, and then again, we can look at this, check ourselves, use the addition method where it's going to be V2. Got to associate that negative sign with V1. So again, V1 is going to have to flip, right, which is what we do here. We want to draw V2 first and flip V1, the direction of V1, right? Make sure it's going that way. And then we want to take the tail of it, put it at the tip of V2, and draw from the tail of our first to the tip of our last, right? Which again is the addition method, right? And again, we have the same vector in the same direction, which means we did things right. All right, one last one here, all right? We have VF minus V initial, or the change in something, right? This is how we see it, but you can write the change in something a lot of different ways, but this is typically how we see it, VF minus VI, right? But you can think of B as VF, so you can write this as VF minus VI. V2 can be VF, so VF minus VI. Don't think, oh, he just did one problem with the change. No, always are the change. Just swap B to VF. B is VF, right? B is VF. These are all, B is the same as V2 is the same as VF. A is the same as V1 is the same as VI. Over here, A is the same as V1 is the same as V initial, okay? So just because this is VF minus VI doesn't mean this isn't. This is still VF minus VI. B is VF. So you can just swap if you wanted to. You could say, hey, this is VF, this is VI, right? This is VF minus VI, right? Or this is VF and this is VI. Okay, it's the same thing, right? And if this is the change in velocity, that's the direction of acceleration, for example, right? So it doesn't, I don't want you to think that just because you're seeing A or B, right, which is what I had here, now I change it to VF minus VI or V2 minus V1, they're not the same thing. So if this is B, B is VF, right? If this is A is VI. Okay, so don't forget that. We can say the same thing here, okay? So don't think I just did one change in something, all right? Because I didn't. All right, we did a bunch of changes. This is the same problem, right? B is equal to VF. A is equal to VI. I can write that down here. Right, so over here, this is still VF minus VI. Okay, just because I have B and A written doesn't mean anything, all right? So this last one, VF minus VI, again, we're just going to put the tails together. It's really simple. And draw from the tip of the one with the subtraction sign in front of it to the tip of the one without the subtraction sign of it, which is going to, if this is VI over here, and this is VF, that's the VI is the one with the subtraction sign in front of it, so we're going to start with that one and go to VF. Or draw from previous to later, where VI is previous, VF is later. Either way it works, okay? And then again with the addition method, we just have to make sure we associate that negative sign with the VI, where we got to make sure we flip it when we do it tip to tail. So we start with VF, flip VI, put it right there, right? This is VF, this is VI. So we take the tail of VI and put it at VF, and then draw from the tip of our first to the tail of our last, the tip of VF to the tail of VI, right, for the addition method, and that's how you do it. So again, go back and rewatch this. Remember I did the change. This is on this side. We're looking at changes and things according to like physics. That's what this is kind of looking at. But we can ask you to subtract vectors either way. So you want to look at the combination that we're telling you. How are we asking you to subtract it? And then you can do either one, okay? But remember, the best thing to remember, if you really want to get subtraction done fast, okay, is you just put the tails together of the vectors together. Then you draw from the tip of the vector with the subtraction sign in front of it to the tip of the vector without the subtraction sign in front of it, and you're done. It's that simple. You'll have the answer right away instead of going back and forth, adding, flipping things, right? You can do it this way. The addition method works, right? The addition method works, but the tail to tail is really quick, all right? Hope this was helpful. Please watch it multiple times. Again, make sure you watch the addition method as well so that this one makes sense, and I'll see you on the next video.